Hi everyone, let's do the solutions of the week 6 tutorial. After you read the intro, you know that I gave you a data set and asked you to investigate it and do some data science with it, or science. I gave you a hint that the data is randomly distributed, so your job was to understand this data, what is contained in this data file, and then find the best way to visually represent it. I separated the tutorial into several levels of how how hard maybe for you is to play around with it. So you have mild, spicy, hot, extra, and then there's an additional level, hell. I'm going to record each of the task or the levels separately so you can do it in pieces rather than have one long video. So let's start with level mild. I gave you some hints here in the cells, so you are using the Jupyter notebook, right? I explained what the Jupyter notebook is. It's very cool. You can write your text here, you can write your code, you can run the code in separate cells, and it's all super handy, and it works in your browser. So the first cell, I said import relevant libraries here, so no matter what you do, you're probably going to use NumPy, SciPy, you're going to use matplotlib. So let's import them. So it's import NumPy as an np, import SciPy as sp, import matplotlib.py, plot as plt. I also asked you, I think I gave you a hint to import pandas. So I'm not sure if some of you played with pandas before, but it's my preferred method of handling the data set. So you say import pandas as pd. So, and we run the cell. So you can run the cell either by clicking run here, I don't know if you can see it, or I use a Mac, so it's command enter to run the cell. We have to just put your cursor somewhere and click on it. So you need to load your data here. The way you do it with pandas is very simple. So you call your data is going to be equal to pandas, so pandas pd dot read underscore csv, and then your data file, which I called the pdfs dot csv, and then you want to run it. You want to immediately see if how your data looks like, so you just write data. You don't have to do print data, you just write data in the cell, you run the cell, and there you go. It displays your data set as a table, and it's very handy to see. So what we can see here, that we have 16 columns, sorry, and we have 50,000 rows times 16 columns. We see that the first column is not going to be useful because it's the same as the indices, so we can basically just clip this first one and then take all of the only the columns with the PDFs. The way I would do it, maybe I can just open another cell. Sorry, I'm just going to clean this up, and then in another cell you can extract, like just put a small comment here, extract the relevant columns of your pandas data frame, right? This is pandas data frame. You can check what is the type of your thing here. You just write type data and it would tell you that it's a pandas data frame. So that's very handy to check. So yeah, you want to extract the relevant columns of your pandas data frame, which means you want only these 15 PDFs. You don't want this repetitive column, because it is really the indices. So the way you can do that, you can just say your columns are equal to where your data is called data, right? Sorry, we called it data. So you write data dot, and then this is from pandas, it's columns. I can show you what it is, columns. You write it here and then you run it. It says, you see, it gives you a list as strings, right? It just extracts the headers here. So it extracts this line here. but you don't want the first one. So you can say I want all of them but the first one. So, oh, sorry, so start from the, you don't take the first one, take the second one, and then remove the second one, and then take all of the rest. And now your columns are this. You can also, you say calls list, you just say it's a list of columns. So if you call it calls list, you run it, you just get a list of your headers here, and this is useful to keep in the future. So whatever you do, I would suggest you to do that in the whatever data sets you're working with. It's cool to have this extracted as a list because you can manipulate it later and use it. We will for sure use it. Okay, so let's rerun this. And now I asked you to, the initial plots go here. Say you want to see the most appropriate way of visualizing data on hand. This is only to start understanding your data. So basically you have these, you can already see this when you run your data. You loaded your data, you see all these PDFs, but now you have to understand it. So you can see that you have 50,000 values for each of the PDFs. So those are some distributions that I said is normal distributed data. So you have basically 15 Gaussians. Now you want to see what the differences are between them. Well, there are several ways you can do that. You can separate, I gave you a hint also, you can separate 15 PDFs into pairs of 5. So I already gave you basically a hint what you need to do. You need to take the first 5, then the next 5, and the last 5 as a group. So I also gave you a hint here, so you can uncomment this, load it, and then I said, okay, yeah, sure, let's just do some sort of histogram, right? So you can compare the histograms. The first 5 PDFs, so the way you can do it is you can say, okay, let's just do a figure. Figure is going to be equal to matplotlib figure about PLT figure. We want to set some perks of the figure, like the size is going to, let's just do 7 and 5. Oh, sorry, no, this is not going to work. You have to say fig size equals 5, 7, right? It's just going to make you an object here that you can use. And then we want to do a histogram. I said you can inspect it with a histogram. The way you do it is you call a matplotlib hist function. And now this function actually not just doesn't only give you a plot, gives you something else. So if you go to pyplot hist, so then you can read about this, or you can just call help plt hist, and then it will give you this docstring. It will tell you what kind of parameters you need and so on. I'm not going to bore you with that. You can do that yourself. So either call the help function or just open or just Google it, and then you'll see what arguments you need, but I know how it should look. So basically, as I said, it doesn't just give you a figure, it also outputs something else. So you can say counts bins, and then it gives you the third thing, but we don't need that third thing. So if you, for example, if your function is outputting 2 things, but you only want the first one, so you want the first thing 1, but you don't want the thing 2, so you just put an underscore and is equal to whatever function, and then yeah. So the way that we're going to do is, as I said, PLT, it outputs 3 things, so it outputs counts, or number of entries, number of counts, bins, and then the third thing we don't need is equal to PLT hist, and then we want to just do the first 5. Let's just do the first data. This is how you call it from Panda. So data, and then you open the square bracket, say my PDF1. I just want to plot the first column for me. So in this instead of index, you just call the header data PDF1 because that's how it's called, and you want 50 bins. This is for the bins, and then it plots it for you. Okay, it looks oh, this doesn't look good. Let's change to 7 and 5, not 5, 7. Yeah, this is much easier to read. Okay, you see, yeah, it's a histogram, it's a Gaussian. you want to do the first 5. So what you, of course, are going to do, probably, if you already did it, you copied it 3 times or 5 times, and then change PDF1, PDF2, PDF3, PDF4, and PDF5, run it. And now, yeah, well, they are on top of each other, so they have something similar, right? They are clustering it out basically around something, around the same mean, as you can immediately see. But you want to see through them, so you can set something that's called alpha is equal to, let's do 0.5, so this is for this transparency. And let's just copy that into each of these. Okay, run it. Yeah, now you can see definitely they are, these first PDFs, 5 PDFs have the same mean, it seems, but the spread is different, or the standard deviation. Okay, cool. And now if you want to do 15 of them, you can, but then please don't copy this code. I mean, it will work, but it just looks ugly and it makes no sense to do it this way. So the way you can do it is, because we have, sorry. And then the other thing is, like, let's, instead of PDF5, load the PDF15 to see what's going on there. And then here you see, okay, something is off. Let's just run the first and the 15 to see the difference. You can see that the mean is a bit shifted of the PDF 15 compared to PDF 1. So that means that the first batch of PDFs, the first 5, have the mean around 0, whereas this PDF 15 and 14, 13, 12, 11, 10, they have different, or 11, not 10. They have a different mean. So that's the whole point of the that's how I generated the data. So then, because I already said separate into pairs of 5, so that means you need 3 subplots. So let's do it this way. So this way is, I mean, it's going to work, as I said, but you should not copy and paste the code. So what we can do is open a new cell, and let's now code it in a different way. We want to see fig, and you say axes are going to, we want to make subplots, so it's going to be plt subplots, and then we're going to have one row with 3 columns, so it's going to be 1, 3, right? And then we want to say fig size is going to be equal to let's say 20 and 5, for example. And do we want them to share the axis, one of the axes? We can say that yes, you can do that, share y-axis is equal to true. Let me just clean this up. Okay. And then when you run this, you can see you are going to get 3 boxes that you can fill in your subplots. If these gaps are too big, you can also adjust that. You can say plt subplots adjust, and then you can say w space, so width is equal to, I don't know, 0, and then h space is equal to 0. This is if you have like 3 times 3, for example, plots. So you can say the horizontal height space, sorry. Okay, you see now they are glued together. Cool. Okay, now we need to do something else. So you can say, okay, because we have some, we have to iterate, right? We have 15 of these PDFs, so let's just do through loops. So one way you can do it for I in, for example, columns, right? We call the columns from the header, and then you want the first 5, so you take all of them until the 5th. And then you say counts. Let's just do for the first one, the counts 1, bins 1, and then the underscore is going to be equal to. So now you don't do PLT because you call the axes. So axes are going to now have the indices. So your axis, axis, the first axis, so the first subplot is dot hist, right? You want your hist. And then let's just do, because this is going to be a bit crowded, so you say bins, not bins, sorry, data, data I, right? Instead of PDF1, PDF2, PDF3, PDF4, PDF5, writing, because your I is going to be this. Let's just you can basically just print I, just to convince yourself. Print I, yeah. So it is filling in here, right? So this is how you do it here. So your data, 50 bins, and we said alpha is equal to 0.5 for the transparency, right? And then you can put your labels. Oh no, labels we're going to do later. So let's see if this works. Works perfectly fine. Okay, cool. So now you can repeat this. You can add another loop, and then first loop over the was separate into columns, but now it's fine. I'll just you can play around with it. So now columns from 5 to 10, right? From 5 to 10 is going to be well, you don't have to change. Oh, you have to change the axis, right? Axis. So you want to write it in the second subplot, run it. Cool. Now it's doing this, and then let's do for the third one. So it's going to be from 10 to 15, and then we run this. Oh, of course, no, I need to put it in the third plot, subplot. Yeah, there we go. Is everything okay? Something seems 10, 5 axis. Yes, this should work okay. Yeah. Now, I also asked, you just do you can inspect it now. You can see that here mean is around 0. Here is a bit to the minus side, so maybe -1 or something, and then here my +1. But you can also see that in a different way. This is just one way of inspecting the data. I always think that plotting is a good way to go. Now what you can do here, you see that all the colors are the same and it doesn't look the best, so we can find our own colors. Color scheme. That's how I like to do it. So the way you can do it, you can go to Smasher. Is a library that was made by somebody I know is very good, and you can find a usage here and taking column maps colors. So first of all, this guy made very cool. Let's first see the sequential column maps, because you can see that all of these three histograms, or three subplots with 5 histograms each. Each of these histograms within a subplot shares one common thing, and then which is the mean, and then the spread is getting bigger. So what you can do is you can find a column map, but these column maps look very cool. They are nicely done in every sense, not just aesthetically, but also blind or people with color blindness is friendly for them. And what you can do is take one of these column maps, but these column maps are maps, right? They are continuous. What you need is, in this case, you need 5, 5, and 5 of these, or 15 of these colors. But they have to be discrete colors. What you can do is you can choose a column map here. For example, December one looks good, or Eclipse. I like Eclipse. And then you can take 15 colors starting from the darkest to lightest, because this is the sequential column maps, and we want a sequential one because we are increasing the standard deviation of each histogram, of each distribution. So let's see how usage. He has a code there. You can say taking column maps. You need to have this measure installed. You can see how to install it here. It's very simple to install it on your machine, and then you just call this. Let's just copy this, and then we can say, well, just copied here colors. So my colors are going to be CMR, so that he needs to import a smasher. Let's go up there where we have the imports and say import smasher as CMR, run this thing. Go back to where did we have this here? Rainforest, we don't want rainforest, we want eclipse. And do we want 5 or 15? Let's just do 15, for example. Oh no, let's take 5 because we're going to take 5. And CMAP range is basically, so you're clipping the color. Sorry, let's see the sequential. This range is if you don't want it to start from this to this, but you want to take, let's say, a middle portion here. You don't want the darker, you don't want the lighter parts of the color map, so you can clip it with this argument CMAP range. We want to take the whole thing, so that's going to be fine. You want to return the hex code. So these are going to be your 5 colors. I'll just do 15. I'm going to do the same range of colors for all 3, but in reality what you should do if you're thinking about data viz, so this first 5 PDFs need to have 5 colors from the same color map, and these 2 should have different color maps compared to the first one because it's a different thing, right? This mean is obviously different. Now in hindsight I maybe should have generated these PDFs so the mean is more easier to detect that it's different from 0, maybe minus 25 and 25, but hey, hindsight. Okay, so let's do these colors. Right now we're going to have 5 colors, 15, no, I said 15 colors. So now I want to loop over these colors, right? I want to, in my, here in my loops, I also want to loop over the colors, but here I'm looping over the columns. So I need to add another iteration point, if you can say. So I can extend this and I can say over I and J, for I, J in. And then if you want to iterate over 2 things simultaneously, so you can say zip, put it in also. I is going to go over columns, and then J is going to be going over the length of the colors, which is 5. So you can say for J in range, range 0 length of colors, right? Yes, but you want the first 5, so you don't want all the 15 because we only have 5 5 PDFs in the first plot, so you want colors. But you want to take the first 5 from like this, right? And then you just need to add your colors here. So your color is equal to colors index J, right? It's going to do something like that. And then your labels, you can also include the labels. Label is equal to your columns, right? This is how your columns are called. And then you need to, oh, sorry, I think colors we need to first 5 and then over J, right? It's going to be the first 5 and then each of them separately corresponding to each PDF. And then columns in the same way, right? The first 5 and then another index of J. Let's see if this works. Yes, very nice. So now you can extend this thing. So for I, J in, let's just put this into zip columns, and then here in range from 0 to the length of your colors, but your colors need to be from 5 to 10 now. And then you are going to add your colors. Color is equal to colors, colors 5 to 10, and then loop over each these 5 with the index J, and then your label is going to be equal to your columns, right? Columns, and then in the same way as this 5, 10, index J, and then here the same in IJ. You zip here, and then you have let's just copy, no, in range 0, no, this is not going to len colors from 10 to 15, right? Yes. And then you can say you need to add colors, are going to colors over J. This is going to be 10 to 15, and then just add labels. Label is equal to columns, and then the same loop from 10 to 15, all of them. Let's run this. Very good, looks very good. Okay, now we need maybe some sort of legend, right? So you want to see, you don't want to repeat the code. We know they have 3 subplots, so you can say for I in range from 0 to 3, we have 3 subplots. You can say axis, and then you just put I here, dot legend. Very nice. And it's showing you which PDF is which is always good. What you can also do is maybe add your access labels or something, but you can do it yourself. So this is the way you can do it. I wanted to show you another way of inspecting your data, because you're working with pandas, and this is their pandas have something very cool about it, that you can get descriptive statistics immediately. It can calculate it for you. So instead of plotting, which is you should always do, so don't get me wrong, you should do it, but you can get descriptive statistics with pandas. So what you can do is say data dot describe, and then it literally spits out all of your statistics there. We don't need the first column, so you can just clip that, and you can say from first to the rest. Oh, of course, columns, your data columns, right? Yes, so it gives you all the descriptive statistics for all your 15 PDFs. So it says counts, we know there's 50,000 of them. It gives you the mean of all of them, standard deviation, minimum, maximum, and then your percentiles, 25, 50, and 75% percentile. And you can see that the first 5 PDFs have sorry, they have a similar mean, which basically should be around 0, and then the second 5, they have -1, and then the last 5 are around 1, and then you can also compare the STDs. You can see the first PDF has 1, then 5, around 10, 15, 20, and again 1, 5, 10, 15, 20. So that's how I generated it, right? So instead of describe, you can just do means, right? You can do your mean, and then it gives you the all the means of every PDF here. So you can see the first one's around 0 point something, and then you have -1, and then +1. The same for the standard deviation, so you just the D, and then it gives you the values of the standard deviation for all of the PDFs, and so on. So this is how you could have, if you knew how to use pandas, and I really, as I say, I really love pandas for that. It's very easy to investigate your data immediately. So that's it from me for this first part. I know it was really long, but I really was alive coding with you. So I think the rest is going to be much quicker. Okay, see you all soon. Bye bye.